Okay, so now we're going to be discussing about other logic gates. Now, just as a reminder, we've talked about the NOT gate, which looks like this. We've talked about the AND gate, which looks like this. And just to kind of explicitly write it, this is AND. And we talked about the OR gate, which looks like this. Here, we're going to be discussing about the other type of logic gates. Now, just in general, all of these gates can be deconstructed into a bunch of NOTs, ANDs, and OR gates. But we usually try to keep them as a unique symbol when it comes to representing some kind of logic, because it helps us experimentally with simplifying them. Okay, so to start off, we talk about a NAND gate, or sometimes they call it a not or gate, or sorry, a not and gate. So it's a combination of not and and. Now, the logic looks like this, similar to an and gate, except we have a circle right afterwards. Sometimes they put circles over here, but just to make it a little simple, whenever we see this, we have A, B, complement. Later on, we'll see what this means for us, but for now, this is what a NAND gate is. It's a not and. So I should put NAND gate. Then we have a NOR gate, or a not or. So similar to an OR gate when we have its symbol. Except there's a circle at the end. So we have A plus B complement. Another gate that we have that's also popular is an XOR gate, or sometimes I call it a XOR gate. We have A, B going into this gate, which is in a confusing symbol with a double kind of curve. And this we represent as A special add B. Now, these are some other logic gates that we will see. And actually, NAND and NOR is just a combination of not with and or. While a XOR gate is kind of, to simplify it, sounds like this. You can pick one or the other, but not both. And that's the idea of an XOR gate. Now, there's other weird ones. There's actually something called an XAND gate or a SAND gate, where we have A, B going into this. And actually, funny enough, this is just the complement of this. There's other maybe kind of special gates, but in general, the NAND, the NOR, and the XOR gates are just the gates that we primarily care about. Even the XAND gate really doesn't have any application. So we'll cross it out. Okay. Now, lastly, to kind of wrap up this video, let me discuss about the truth table. So here we have the NAND gate. We have A and B. And then we have an output, Q. Now, the idea of this is that we have A and B, but in general, the complements of their multiplication. So we have 0, 0, 0, 1, 1, 0, 1, 1. Now, the logic for... So I'm just going to call this Q and then I'm going to put Q NAND, just to show you the difference and to help you see a little easier how NAND and AND gates differ. Previously, AND gates were only true when both were true. But for a NAND gate, all of it is true except for when both are true. So in a way, that is what is represented by AB both complemented. Now, what about a NOR gate? Well, for a NOR gate, we have A, B, and then Q OR and Q NOR. So that I can show you the difference. Previously, OR meant that only one of them had to be true in order for both to be true. But for NOR gate, only when both are false is it true. So it's a flipped. Now, what about an XOR gate? Well, for an XOR, it kind of looks like this. Q XOR. So you have 0, 0, 0, 1, 1, 0, 1, 1. Now, it follows this statement. You can have one or the other, but not both. So that means that this would be false and this would be false, but this would be true. And actually, we can actually represent the output as AB complement plus A complement B. So it's a representation of two AND gates plus an OR gate. So we had to kind of look at its logic. It looks kind of like this. And then we have over here something like this. So we have A multiplied to B. And then from over here, multiplied like so. And then added together. Like that. That is how we deconstruct an XOR gate. And hopefully you can see that we don't want to do that every time. So as such, by keeping it as this is another gate for us to kind of keep in mind when it comes to when we talk about application later on. So those are just some other gates, or the 3 other gates that we can care about. Okay, next video we'll talk about how to do analysis on these. Okay, thank you.